One of the most important skills to learn about lines is how to write an equation between 2 points. So that's what we're going to focus on today. When we first learned how to calculate slope, we did it from a table and we just found the difference in the y over the difference in the x. Remember, change in y over change in x. Today I'm going to teach you a different way to calculate your slope with what's called the slope formula. The slope formula is y2 minus y1 over x2 minus x1. So what I'm giving you today is a different way of solving for the slope. If you like the way that we learned it with the table or the change in y over change in x, feel free to continue using that. But for some of you, this is a different way to organize your work and you may like this better. For the slope formula, what's important is that the first two numbers that you use come from the same ordered pair. What is not important is that it comes from the second ordered pair. You can call either one of these points x1, y1 and the other one x2, y2. But you have to start from the same ordered pair. So I'm going to start from the second ordered pair. I'm going to call these x2, y2. So the first point will be my x1, y1. So I'm going to subtract my y values, 4 minus -2, and then I'm going to go back to the coordinate I started from, 2 minus -1. Of course, when you subtract a negative, you add the opposite. So we get 4 plus 2 is 6, over 2 plus 1 is 3, 6 divided by 3 is 2. So our slope is 2. With the point slope form of a line, you can choose either point you want to, whichever one you feel is easier to work with. Typically, when the points are positive, they're a little easier to work with. So I'm going to use our second coordinate. So we have our slope is 2, the x value of our coordinate, and again, I'm using the second coordinate here. So I'm putting a positive 2 into the asylum with the x, so it becomes negative. And then my 4 is positive, it's outside the asylum, so it stays positive because it's normal. And finally, we like our equations in slope-intercept form, so we're going to distribute our 2. We got y equals 2x minus 4 plus 4, and when we combine those like terms, the -4 and +4 cancel, so we're left with y equals 2x. Same process, so we're going to focus on that new form of finding our slope, y2 minus y1 over x2 minus x1. You can choose either y coordinate to start with. This time I'm going to start with the first one. So I'm going to do 3 minus 0 over, and then I have to go back to the coordinate I started with, 4 minus -2. In the numerator, 3 minus 0 is 3. In the denominator, when I cancel my subtraction by adding the opposite, I get 4 plus 2 is 6. And when I simplify 3 over 6, notice this is different from the slope I got first time. The first slope is 6 divided by 3. Now I have 3 divided by 6. 6 does not go into 3 evenly, but I can simplify it to 1/2. Setting up my point slope form, y equals m x minus x1 plus y1. 0 is a really easy number to work with, so I'm going to use the second ordered pair this time, substituting my slope of 1/2. Putting that -2 into the asylum, it becomes opposite, +2, and then plus 0. Distributing that 1/2, half of 2 is 1. And of course, if I add 0, that doesn't change anything. So my slope-intercept form of the line is y equals 1/2 x plus 1. All right, looking at this one more time, and then we're going to have some special equations. So our slope is y2 minus y1 over x2 minus x1. Choosing which y coordinate you want to start with. I'm going to start with the first one this time again. So we've got -5 minus -4, and then I have to go back to the ordered pair I started with. So I have 2 minus 6. In the numerator, changing that subtracting a negative to adding the opposite. Negative 5 plus 4 is negative 1. Over 2 minus 6 is negative 4. Whenever you have a negative over a negative, the negatives cancel. So even though I can't simplify my 1/4, I can simplify my negatives. Setting up the point slope form, y equals m x minus x1 plus y1. Substituting our slope is 1/4, choosing either ordered pair. In this case, they both have a negative value and they both have a positive value. So I'm going to choose the first ordered pair because the numbers are a little bit smaller. So x minus 2, the positive 2 goes into the asylum grouped with the x, so it becomes opposite. And the negative 5 is outside, so it stays normal. It stays a negative 5. Distributing my 1/4, I get 1/4 x minus 1/4 times 2 over 1 minus 5. So when I multiply my 1/4 and my 2, the 2 goes into 4 twice. So my 2 ends up in the denominator, so I get 1/2 minus 5. And because they're both negative, you can think about if you spend half a dollar and you spend another $5, you have spent $5.50. When you put your equation into slope-intercept form, it's helpful to have that intercept as a mixed number instead of an improper fraction. These next two should go a little bit more quickly. We've got some special equations. So first thing we're going to do is find our slope, y2 minus y1 over x2 minus x1. I'm going to start with my first ordered pair again, negative 3 minus negative 3 over, going back to my first coordinate, 3 minus 6. In the numerator, when we add the opposite, negative 3 plus 3 is 0 over negative 3, so we get a slope of 0. Whenever you get a slope of 0, what you want to do is analyze those points a little bit more closely because you're going to have an x equals or a y equals equation. So looking at our points, the negative 3 in the y coordinate is the same. So our equation is y equals negative 3. We have a slope of 0, which means we end up with a horizontal line. Last one, setting up our slope, y2 minus y1 over x2 minus x1, change in y over change in x. This time I'm going to start with the second ordered pair. So we have negative 4 minus negative 1 over, going back to the second coordinate, 8 minus 8. In the numerator, adding the opposite, we get negative 3 over 8 minus 8 is 0. This slope is undefined. Remember, we can't divide by 0. This is like saying, how many times does 0 go into negative 3? 0 doesn't go into negative 3. That's why it's undefined. So when you get a slope that's undefined, again, look for some similarities in your coordinates. This time, the x values are the same. So we have an equation x equals 8. So what you might want to do is analyze your coordinates before you set up your slope. You could figure out your equation a little bit faster. However, if you forget and you jump into slope formula right away, look for a 0. A 0 in the numerator or denominator will tell you that you have a special equation, and you'll want to look at your coordinates a little bit more closely. And you have 2 U-Try questions. Please attempt these before class so we can get started on our warm-up right away.